to the Unit 5 Lesson 2 video. Make sure you have your note sheet with you today and make sure that you're taking good notes. At the end of the video, you'll be asked to write a summary. Your summary should include these important ideas. We're going to be dividing powers at the same base. We're going to be calculating a zero exponent on a non-zero base, and we're going to be finding the power of a quotient. Now, quotient is what I get when I divide. Like a sum is when you add, and a difference is when you subtract. A quotient is what you get after you divide. When you write your summary, make sure you use these ideas in your own words. Recall that from before, a base is the bigger number and it tells you what's being multiplied. So for example, my base in this particular expression is 2. The exponent tells me how many times to multiply. So my exponent is the little number up top. So I have to multiply 2 4 times. And this whole thing is referred to as a power. And I read this as, again, 2 to the 4th power. Now, in class, we discovered this different property when I divide by the same base. 2 to the 5th and 2 squared. So I have 5 2's. 1, 2, 3, 4, 5. 2 2's in the bottom. And remember, these divided out. 2 divided by 2 gets to be 1. 2 divided by 2 gets to be 1 also. I'm left with 3 2's, or 2 to the 3rd power. You can see also that if I have 2 to the 3rd divided by 2 to the 6th, I have 3 2's up top, 6 2's in the bottom, and 3 of the 2's will divide out to be 1. 1, 1, 1. And I'm left with 3 2's in the denominator, 1 over 2 to the 3rd power, or 1/8. Now, here's a new idea that we did not quite discuss in class. If I have an exponent in the denominator, I will get a negative exponent. 1 over 2 to the 3rd will be 2 to the negative 3rd. All right, the last one, I have 6 2's. 1, 2, 3, 4, 5, 6. And I have 3 3's. 1, 2, 3. I have 2 2's on the bottom. Forgot to write the division bar, or the fraction bar. And I have 5 3's on the bottom. So 3 of the 3's will divide out to make 1. And 2 of the 2's will divide out to make 1 as well. So I'm left with 2 to the 3rd, 2 to the 4th on top, my mistake, and 3 squared on the bottom. Okay, which ends up getting 2 to the 4th times 3 to the negative 2. Now, what was the rule we discussed in class? What happened to the exponents? 2 to the 5th divided by 2 squared got me 2 to the 3rd. How does 5 and 2 make 3? I subtract the exponents. 2 to the 3rd divided by 2 to the 6th, 3 minus 6 is negative 3. So when I divide by same base, subtract the exponents. Notice they had to be the same base. Look at the last example with the 2's and the 3. I only subtracted the ones that had the same base. 6 minus 2 gets me 4. 3 minus 5 is negative 2. Let's use this to simplify some things with non-numerical bases, with a base of z. Well, z to the 8th divided by z to the 5th is z to the 8 minus 5, which gets me z to the 3rd. Which again, you could show by literally writing 8 z's divided by 5 z's, right, and crossing them out. T to the 4th divided by t. Now t is raised to what power in the denominator? 1. If there's no exponent, you assume it's to the 1st power. This would be t to the 4 minus 1. It's t to the 3rd power. Divide by the same base, subtract the exponents. So if I have 2 to the 5th, that's 32. Then 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. Now, if I want to go from 2 to the 5th to the fourth, I just divide by 2 and have 1 less 2. So I'm going to take this, divide it by 2, and I get 16. If I want 1 less 2 than that, I divide 16 by 2, and I get 8. And 1 less 2 than that, divide by 2. Divide by 2. Divide by 2. See what happens? 2 to the first is 2. Now 2 to the 0 is not nothing, it's actually just 1 because the pattern is to divide by 2. For another example, over here, 10 to the 5th power is 10 times 10 times 10 times 10 times 10. 5 times. 1, 2, 3, 4, 5. That's 5 zeros. It's 100,000. To get to the next power below it, I only have 4 tens, so I had to divide by 1 10. So I divide this by 10. It cancels 1 out, and now I have just 10,000. Divide by 10 again to get just 3 tens. I have 1,000, sorry. Then 100. Then divide, oops, I don't need a comma for that one. 100. Divided by 10. 10. And again, if I divide by 10 once more, remember, I'm just dividing by 10 to get the smaller power. If I divide by 10 once more, 1. The rule is any non-zero base to the 0 power is 1. And that means that x raised to the 0, no matter what x is, as long as x isn't 0, would be 1. So note that 0 power, we don't know what that is. So provided that x isn't 0, something to the 0 power is 0. All right, so we do this subtraction. N to the 7th divided by n to the 7th would be n to the 7 minus 7. That's the first base. The second base is x. It'd be x to the 4 minus 1. So then I have n to the 0 power, x to the 3rd power. N to the 0 power ends up being just 1 times x to the 3rd power. So my answer, x to the 3rd. Over here, we discussed this in class. If I have a product raised to an exponent, it's like multiplying this exponent times everything inside. So I'll actually distribute this 0 to all of those. Power to power, I multiply the exponents. 8 to the 4 times 0, x to the 3 times 0, y to the 4 times 0, and z to the 1 times 0. That makes all of these raised to the 0 power. So when I multiply by 0, I get nothing. Right? And so these will all turn to be 1. Very quickly, assuming that this is not 0, if it's raised to the 0 power, it should be 1. All right, simplify completely. So we have 4 divided by 8. I can simplify that, right? 4 and 8. Divided by 4 becomes 1. Divided by 4 becomes 2. So in order to simplify that, I'm going to have 1/2 now. So 1/2 is the simplified fraction out front. Now let's go to the m's. M to the 9 divided by m to the 2nd. Subtract the exponents. 9 minus 2. Third base is n. N to the 7 minus 3. So then I have 1/2 times m to the 7th and n to the 4th. That's my answer. Nothing more I can do. All right, let's go to the next one. A to the 8th power, b to the 1st, c to the 9th, divided by a to the 7th, b to the 1st, c to the 4th. First base is a. Subtract the exponents. 8 minus 7. Second base there is b. b to the 1 minus 1. Third base, c. 9 minus, oops, should use a different color. 9 minus 4. So this becomes a to the 1st power, b to the 0, c to the 5th. So then the b goes to 1, so it's just a to the first power times c to the fifth power. So just a times c to the fifth is all you need. Okay. Hopefully there are no questions there. Anything that's 0 power. Now this looks like a beast, right? But look, 0 exponent. That means everything inside of here is going to get a 0 for an exponent, especially that one, right? So all these exponents. And so this will just turn into a big old 1. Just as easy as that. As long as the base is not 0, anything that's 0 power is just 1. All right, let's look at the next page. Now you have two choices. You can either simplify each part of the product individually or multiply it together and then simplify. I'll show you multiplying together first. So if I multiply fractions, just multiply across. So it'd be first fraction has the 4, and then the m to the third, n to the seventh, and the second fraction had just n to the fourth. The first fraction over here had p to the eighth, and I'm going to multiply times the second fraction's version of negative 12 m p squared. Now because it's multiplying, I could organize this however I want to. So I'm going to put the numbers up front. So 4 and negative 12 are going to go up front. 4 and negative 12. Okay. The m's will put together. M to the third. Then below that I have m to the first. Then I have another base, n to the seventh. And then times n to the fourth, which would end up being, when you multiply the same base, you add the exponents. And on the bottom, I have this third base, p. It's p to the eighth times p to the second. 8 plus 2. So when I multiply by the same base, I add the exponents. Can I simplify 4 over negative 12? You should be saying yes. Divide by 4, I get 1. Divide by 4, I get negative 3. So my fraction becomes negative 1 over 3. Now it's going to be m to the third divided by m to the first. So it would be m to the 3 minus 1, n to the 11th. Then this p stuff is all on the bottom. So we put that on the bottom. 8 plus 2 is 10. So multiply top times top, bottom times bottom, I get negative m squared n to the 11th over 3 times p to the 10th. So again, fractions are really important here. If you don't understand fractions, this is going to be a little bit harder. So notice that the 3 and the 1 are on different sides of the division there. But think of it this way. If I wrote it all out as multiplication, it'd be 3 m's, right? Divided by 1 m, and then one of the m's will cross out. So that's why I still have 2 m's on the top. Over here, there's no n's in the denominator to cross it out, so all 11 n's are going to stay on the top of that fraction. All right, let's do the next one. Multiply these together. So the first fraction had the k to the 12th, n to the 6th. Second fraction has the k squared, l to the 9th. On the bottom, that's not a 1, it's an l. So on the bottom of the first fraction, I have l to the third. The other one, I have m to the 10th. Again, we can combine the things that have the same bases. So you can see over here that k and k can combine together. And you can see, too, that these l's will be able to cross out a little bit, too. So on the top, I have k to the 12th and k to the 2nd. That makes k to the 14th, because when I multiply by the same base, I will add the exponents. M to the 6th divided by m to the 10th. Do I have more m's on the top or on the bottom? Well, it looks like on the bottom. So all of the m's on the top are going to go away, and I'm going to have how many m's on the bottom? 6 minus 10, negative 4. So it'd be m to the 4th on the bottom. Again, I subtracted the exponents. M to the 6th, m to the 10th. 6 minus 10, m to the negative 4th. That means I have 1 over m to the 4th. It means all 4 m's will be in the denominator, which makes sense because there's more down below than there is up top. L to the 9th divided by L to the 3rd means I have 6 more on top, so I have L to the 6th on top. That's my answer. Thanks for watching. That's all we have for today. I know we have another sheet here with negative exponents, but I kind of went over that at the beginning. So k to the negative 4th would be 1 over k to the 4th.